Okay, so let's begin. Concurrency and socket programming. Before that, let's first look at passing command line arguments in a C program. So it's like more like till now we have been accepting arguments from the user via normal by taking the input, and now we'll see how we can pass the command line arguments, and instead of asking the user enter, they can enter the arguments along with when they run the program. Let's say if the compiled binary is .a.out, the user might be able to pass the arguments while running the binary. Let's see how it is done. It's a very simple process. It's just like two or three lines of code which you need to do, and it'll be fine. Let me show you the code then. Let me zoom in. So let be command line dot c. Oops. That's okay. So first thing is let's make the program to accept two numbers via the command line and print the sum of it. So I'll first include the header files, which are stdio and stdlib and int main. So to pass in the command line arguments, you need number of arguments and the argument vector. So the main would need two arguments, two parameters, which would be int argc. That's the number of argument the main function is accepting, and uh, character star argv. That's the argument vector. So it'll be something like if my compiled binary goes like dot slash a dot out, let's say 2 and 3. This this part will be the arg v0, and this will be the arg v1, this will be the arg v2. In total there'll be then three arguments which is passed. So let's say we are printing the sum of two numbers, so we can write if argc is not equal to 3, because we need three arguments. This is 1, this is 2, and this is 3. We would say the user that printf 3 args needed, and we just end it here and return 0. Otherwise, let's calculate the sum and print it to the user. So let's just show you what the parameters are actually first. First param would be person s slash n and argv of 0. This will definitely show this is a dot out. And then let's print the sum. Sum is slash n. Between, it'll be a string, so we need to convert the string to an integer. So for converting string to an integer, we have a function which is called atoi. So it converts the string to an integer. So argv of 1 plus atoi argv of 2. So this will calculate the sum and print it and return 0. So this should print the sum of two arguments which will be passed via the command line. Let's compile it and see. Command line dot c. Okay. Too many arguments for the format. Okay, what's the error? Sum is okay. So I forgot to add the decimal. It should be fine now. And now let's run it. And three args needed. So I didn't pass any argument, so it gave me an error. It went here in the if block and it returned. So let's try it again with 2 and 3. The first param is a dot out. As I told you, the first parameter would be this one, and the sum is now the has been calculated. So that was it for command line arguments. That's very simply That's a very simple program. And now I'll move to concurrencies first, and then we'll drive into socket programming. Any doubts for command line arguments till now? I hope that's a no then. Okay, I think that's a no then. Okay, so concurrent programming. Concurrent programming. So it's basically we can say threading. Thread is the small sequence of instructions that can be scheduled independently. So it's more like you can do multiple things at the same time by creating threads of it. Same as like we did in Java, we created thread and executed many processes simultaneously. That's mainly like parallel processing. So, what are the basic thread basics? So, we'll be using P threads here to create threads, and let's just dive into the coding part, and we will discuss it over there how we can create a thread and what is the basics of a thread. So, let's just create a thread for, let's say, printing hello world, and we can see how to create a thread. So, let be called simple thread.c and hash include stdio, and for this we will using a library called pthread. And let's say we have an int main, and to create a thread, there's been a structure which is provided that's called pthread of type t, pthread t, and let's name our thread as thread. So to create a thread, it's the syntax goes like pthread create, and it expects a name of the thread. And then there are certain parameters like these are the parameters which are more like we need to pass like the argument and the default values. So for now we will save that as null, and then a function which your thread function. So let's have a thread function which is called a void star my thread, and it'll be taking a void star arg. So we can pass only one argument here because that's how C allows it. So it'll be one argument only. But if you need to pass many arguments, you can wrap it around a structure and you can pass it that way. But this should initially be only one argument. So that's how C works. We'll later see how we can pass in multiple arguments using by creating a structure of it. For now, we just printf hello world, hello from thread, and then we just return null because the return type is a void pointer, so you need to return something. Um, and after this null, you need to pass in your thread function. So this is the thread function which is calling, and then a null. So, and now you need to wait for the thread to finish. Either you can run the thread independently using a detach mode, or you can just pause the main execution over here, and then you can wait for this thread to finish and then continue. So we'll first see how you can wait it, then we will see a detached mode. So pthread join thread and null. So this is null because this is used to store the value which is returned by this thread in a variable. Currently it's a null. So we are having a null here, but if you want to store a variable here, you can return it from here and then store it. We will see how we can do that later. And then I'll just printf thread execution finished. And then return 0. And let's try to compile it and run it. GCC simple pthread, and you need to provide a flag which is pthread over here while compiling, and dot slash. So it obviously it called thread and then it waited here and then it finished here. So that was a simple thread function. Any doubt till now here? Any questions? Okay. I think, is it yes or no? I saw somebody typing. So, okay, I'll assume that's a no then. If there are any questions, just drop in the chat. I'll just open the chat later and I can see it. Okay, now we saw like we are able to create a thread, but sometimes we need to pass some data to the thread. So how we can do that? Because you see, there's a void star arg over here, and we passed a null parameter as well. Because this is the data parameter and this is the attributes parameter which is there. So let's see how we can pass some data to the thread and we can do see how we can calculate something or do something with the data. Let's see, let's say we pass data to thread.c. Um, let's have int main and let's use some command line arguments over here. So let be int argc char star argument vector and that's an array and let's just create what should we do? Let's just expect a number from the user and just print it in the thread. So if argc is not equal to printf, function call should be of dot slash a dot out and from and finish it over here and then return 0. So in this way, we are taking one argument from the user and let's print it and see how we can print the number as well using a thread. Print the data via the thread. So we just create a thread, pthread t, let me include the library over here, hash include pthread.h and hash include pthread t. Let's create a thread which is a thread and have a message called message hello world. So that's one of my messages here. Um, let's create a thread. P thread create. Um, we need to pass the reference of that thread. That's the thread. For attributes, we are just using the normal attributes as the null parameter. So it'll have the default attributes. Then the function. Let's create the function for the thread. Let's have a print message function. So void star print message and it takes void star arg. So first you need the print message will be sent here. So it'll be the print message function and then the parameter that's the argument here. So the argument, let's say we want to send the message. So it'll be the message. So in this way, the now the void star arg will have this message over here but it will be a pointer. So we need to dereference it. So cast message equals to, so it'll be convert the type from void to a char and then arg. So in this way, it'll be now having the cast message as the argument. And now we just printf. Let's say thread says percent s slash n message and then return null. We will see how we can return some value from the thread and how we can manipulate that in later. But for now, we are doing it as null. So that's one thread we have created. Let's create another thread and see the execution of it. So let's just wait for the thread to finish here. So we can do pthread join thread and null. And let's use the same thread to create to print the number which was there. So int number which was received in by this argument vector. So int number equals to a2i arg vector of 1 because that's be the number which will be passed, and then pthread create and thread. Let's have the default parameters and print number. And let's pass this number as one of the functions. So we need to pass the reference of it because that's why it's having a argument of cast void star. So it'll be number. And let's just wait for this thread to finish. So p thread join thread and null and then return 0. So we need to create this function also now. So it'll be same as this. So it'll be void star and it'll be void star arg. So in C, for the threading function, you can only pass one argument only. So if you need to pass multiple arguments, you need to wrap it around a struct and then pass it. So let's just dereference the number because it's a void star. So we need to first convert it to a int and then we need to dereference the int. So it'll be star of uh, int star arg. In this way, you can dereference the whole of the argument to just a number by first changing the void star to an int star and then dereferencing it. And printf number is %p/n. That be null, and then return null. So let's try to compile it and see what it'll do. GCC pass data to threads dash pthread a dot out, and it requires a number. Let's say we pass in a number called 4. So the number says 4 and hello world. So how did the function happen? So it first went here, checked how many parameters are there, and then it created a thread. It initialized the message and then it created this thread. And this thread went here. But when it went here, the main was still continuing and it went to line 32 and it says p thread join thread null. So it needs to wait for this thread to get finished. So the main execution stopped here and waited for this function to get finished. And then it continued again here. It printed the number and then it waited for the thread to be finished and then executed the whole program. So that's how the control flow of this program went. Any doubts till now? Any doubts or is it okay? Okay, so okay. Can you send the code, please? Yeah, I'll upload that to my GitHub, so you can it'll be there in the announcement, so you can check from there. Okay, so that was the basic threads syntax. Now let's okay. Instead of starting with a thread pool, let's see first. Um, First, we are doing like single arguments only. Let's see how we can pass in multiple arguments. As I was saying, we can do that with structs. So let's say multiple args.c. So first include hash include stdio hash include pthread. Let's just have okay, let's just have something here. What program shall we make? Um, Actually, first do a multiple threads, then we can do the multiple arguments. Let's do a multiple threads first, and then we can do multiple arguments. Let's try to create multiple threads first. Um, we will create, let's say, 5 threads, and we'll see how the execution goes in those 5 threads. So let's have a function called print number, which takes in a void star arg, and our dereference the number which is added again before, so it'll be star in star arg. So I convert the void star to an int star and then dereference it to an integer. So let's say printf thread received number %d/n and then a number and then return number. So this is a print number, which is a function of our thread, and let's try to create multiple threads and then see how we can create multiple threads. So let's have a main function and then pthread, and let's create a threads array of 5. So we'll create 5 threads. You can create as much as you want. So that's how you can create an array of threads. And let's have 5 numbers, and numbers of 5 is equals to 10, 20, 30, 40, 50. So these are the numbers, and we need to create thread for each of the numbers. So you can create that in a loop as well. For int I equals to 0, I is less than 5, I plus plus, oops, I plus plus, and pthread create. We need to create threads for each of the numbers. So it'll be threads of I. Again, we'll go with the default attribute because we don't want to change the attribute, which was we'll go with the attributes provided by the C. So we'll have a null. For the function, we just declared a function which is called print number. And argument wise, we just pass in the number which is there here. So it'll be numbers of I. Now it will create 5 threads, and we need to start. We need to wait for those 5 to finish. Again, you can run those in a detached mode. You can have your main execution going, and those will be running in the background. But for now, if I just detach them, it will my main will finish, and those will be still running. So I need to wait for them. For int I equals to 0, I is less than 5, I plus plus pthread join um, threads of I and null threads of I and null, and then return 0. So this would create 5 threads, and here it will wait for 5 threads and then return 0. So let's try to compile it. GCC multiple threads and pthread. Um, okay, void star numbers of I. Oh, it needs to be a reference. So and a dot out, and yeah, that's creating the 5 of the numbers, and it's creating thread one by one. So this is how you can create multiple threads. Any questions till now? What is the second argument of the p thread create? So it is, and why do we do null for it? When you reference, you mean the pointer. So the second argument of the pthread create is the attribute. What attributes do you want to pass? So null means we are just going through a default attribute which is provided by the C. That's why we do null. And yeah, that's why we do null, because we want to go for the default attribute which is provided by the C. What attributes? Okay, let me open the function definition for you first. So this expects a thread and a thread attribute. So the thread attribute can be of, these are the types of thread attribute. Let me tell you what thread attribute is basically like when you want to specify what kind of behavior your function should have. That's what the thread attribute does. So it helps you to manage the characteristics of your thread in the application. That's like a set of values which to be used for uh, like to be used by the thread that affects the behavior of the thread. So there are different kinds of attributes which are there, but again, those are not mentioned in the lecture, so I didn't went deep into that. So that's thing. I hope that's clear. Or do you want me to open the docs and see? Okay, yeah, it's not that deep because they are basically like those attributes control your behavior of the thread. So basically, we are currently like for our course, we are just doing in with like the default behaviors. But if you want to dive into like some high level stuff, so you need to sometimes change the attributes of your thread accordingly. So that's what you can change it over there. And when you say reference, you mean a pointer to it. Yes, yeah, basically. So when you pass in with a and, it basically passes in a reference of it. So the memory address of it. So that's what it is. I don't know if my connection. Are you guys able to hear me? Cutting out from. Okay, so let me rejoin again. Okay, let me rejoin again. Okay, am I audible? Okay, so okay, now that was creating multiple threads. Now look at like currently we're passing only one argument, and we want to pass, let's say, many arguments. So how do we do it? As I said, we can wrap that around a struct and pass it low. So let's create a function and see how we can pass multiple data types to a thread. So passing structs.c, and let's let's include header files. Hash include the thread and hash include stdlib. And let's define a data which is having an ID and a char. So type def struct um int ID and character type of name which is like, let's say, for 20 for now, and let's call it a data key. And let's have another struct which is called type def struct int a comma b and b arg b. So these are two of the our data types which we have, and we will be seeing how we can pass in multiple data types using this. So let's have a main function first, and let's see how we want to decide the workflow, and then we can give it int main pthread create. Let's okay, sorry, pthread. Let's create two threads, thread one and thread two. So we created two threads, and let's define a data t. Data t, let's say, is one, and the name should be, let's say, test. And the other argt, let be argt equals to data t data argt arg is 10 and 20. Okay. Let's create a thread and we just print in what is there. So first print the data. So it'll be void star print data. And again, it's the standard syntax, which is arg. You need to convert it and change the types accordingly inside the function. So it'll be, I'll have a data t, I'll pass a data t over here. So data t star data. And I need to convert the void pointer to a data t pointer. So it'll be data t star arg. And I'll just printf thread ID is thread ID. A decimal and name is let's say this and data dot id and data name. So this is how you can give in multiple arguments by wrapping it around a struct and then passing it and return null. We'll see later how we can change this return null to return something and how we can do it. So let's create a thread and execute this. Pthread create and let's execute this on thread one and having the default attributes and having the function called print data. And now if you want to pass in multiple data types, so we have this as a data type, so we just print it and data and then wait for this thread to finish. Or let's create another thread and see how let's print this argument. This one prints the sum of it and see how we can print it. So let's have a function called void star sum thread. It takes in also the same parameter arg and it'll be argt star nums equals to arg star of arg. Okay, I need to argt here. It'll be argt. And let's print the sum of it. So I need to first allocate a memory because we are dealing in pointers. So int star result equals to malloc of size of. So this will eventually give me a integer size and star res equals to nums of a plus nums of b. This is a simple program which will just take in two numbers, allocate the memory, and star res will point to that memory address, and it will calculate it and then return res. So here we will see how we can change this null here. So here we are returning null. Now we'll be returning a value which is a res. So let's have another thread, pthread create and thread 2, and it'll be a null. We are going with the default parameters, some thread and arg. So these are the function parameters which is passed. Let's just wait for the first thread to finish. So we can do pthread join thread 1 and null. Because thread 1 is not returning any value. So this is the thread 1 function. It's not returning any value. So we can, it's safe to write null here. But the sum thread is returning a value which is a result, which is a void pointer, but actually it's an int pointer. So we need to change the data type of it and we need to store it into another variable. So it'll be it's returning a void type of pointer. So we can have a void res here and we can store that in here. So pthread join and it'll be thread 2 and we pass in the reference of the res. So in this way, when this returns this result, it will be stored in this void pointer now. Instead of passing in null, we pass in the memory address of where this result, the returned result from the thread needs to be stored. So this will now my result will have the memory address, will point to the memory address where the sum has been stored. And now I'll be printf sum is percent %t slash n. Now it's a void pointer again because this is a return type of void pointer. So I need to convert that to an integer pointer and then dereference it to find in the sum. So it'll be star of int star res. And then I have allocated the memory here. So I'll need to free res as well and then return 0. So this should, so let's predict first how the execution will be. So it will first create this thread. It'll go here, it'll print the data and then it'll return null. And then it will wait for this thread to finish. On the other hand, this thread will also be created. So it will calculate the result of it and store it in this memory address and then return this. So when you create do pre-thread.join and res, it will be now here. And then you just print the sum and then free it. Let's try to compile it and see. Passing structs pre-thread. So thread is one and name is test. I can show you the memory address as well. It'll be let's print f addr is %d slash n and this should print the memory address of it. Um, oh, sorry. Oh, this will be pointer. So this is the memory address, and let's convert it before convert it to int ptr. So I'll just print it after it's been converted to an int pointer. What's the status of it? It'll be int star res. See, the address are same, but you are just converting the pointer type from a void to an int pointer, and the sum is 30. So by dereferencing it. So this is how you can pass in multiple parameters as a struct, and this is how the thread.join also works. You can store the result in a variable over here. Is it clear now, or are there any questions? Any questions, or it's fine? Okay, I assume it's fine. If there are any questions, just type it in the chat. Okay, all good. Okay, so these were the pthreads basics. So now, thread pool, we'll go to thread pool a bit later, but let's first go into mutexes. So what is a mutex? So sometimes we can have multiple threads also. So there is a possible scenario where both of the threads are trying to access the same data, but they end up corrupting the data or changing the data value, so the other thread gets some wrong data. So that's where you have a lock over the data, so that if one thread is accessing the data, so the second thread won't be able to access the same resource. That's why mutexes are used for. Let's see an example how we can how the program behaves incorrectly without the use of mutexes, and then we'll fix it with mutexes then. So this will be the using mutex. At first I'll do it without the use of mutex, and then I'll try to do it with mutex. So hash include std io.h and hash include pthread hash include stdlib. Let's have a counter variable first. This is a global variable, and to declare a mutex lock. Okay, let's first dive into what will happen if you don't use mutexes. So let's have a increment function which will be used by a thread, and will be having a void star arg, and for int I equals to 0, I is less than, let's say, 10,000, I plus plus. It just increments the counter, and okay, that's it, and then it returns null. And let's call in two threads and see the execution. Int main pthread type t1 and t2 are the two threads, and pthread create and t1 null increment and another null, and pthread create and t2 null increment, and it'll be another, I'm passing nothing so as a parameter, so that's why it's a null. Let's wait for both of the thread to finish here. Pthread join t1 null, since it's not returning any values, will be null. Pthread join t2 and null, and then printf. Let's print the value of the counter because counter has been incremented. So final counter is um, percent oops, percent d slash n counter, and then return 0. Okay, so let's see what's the outcome would be, because okay, increment um increment, okay, GCC using mutex and pthread. Okay, this is the counter actually, but what should have been the correct answer? So counter goes from 0 to 10. What this is, it's 100,000. So counter should go from 0 to 100,000. It should have been 200,000 actually. So let me show you one thing. If I move this line to here and then again create a join, let's see what will be the answer. See, that should be the actual answer, but you're getting this if you execute both of the threads like simultaneously. So because they are using the counter resource at the same time, so that's why it's getting corrupted. So for that reason, we use mutexes and locks. So to use mutexes, we declare a mutex lock. So it's declared generally globally. So uh, pthread mutex lock equals to pthread mutex initializer. That's the basic syntax of it. And when you increment, or let's say when you are using any resources, you just lock it over there. So pthread mutex lock, and you pass in your lock variable which you created there. So mutex, oops, this should be mutex t lock, and lock. And after you finish doing it, you just unlock it over here. Pthread mutex unlock and lock. So this will lock the resource and unlock the resource when it's been done. So let's see what's the output now. So that's the basic use of a mutex lock is, because you see before it was 145,000 and the correct answer should have been 200,000. So that's how you can use a mutex to lock your resources and prevent like data corruption. Is there any doubts till now? All good. Okay. So that was one of the mutexes, but there's other which is called conditional variable to synchronize data based on certain conditions. So you can have certain condition based on that. You can have you can lock or unlock. So let's see how we can do that. That'd be con variable sync dot c. So let's have a function which just creates let's have a waiter function and let's have a setter function and then create some threads and let's see what will be the output is. So hash include stdio, hash include stdlib, hash include pthread. So let's have a global variable called int ready equals to 0, and we have a mutex lock. So pthread mutex of type t and lock equals to pthread mutex initializer. That's my mutex initializer. And for creating a conditional initializer, you have pthread cont t. So this, and we call it a cont, and then pthread cont initializer. So basically, I'll go through what a conditional initializer is and how we can do that. So let's have a function called void star waiter. Let's no first have a setter function. Setter function which will take an integer variable and it will just increment it. Or yeah, let's do it like that. And have a sleep also, so we can see how the thread execution goes. So we can sleep at some point. We can sleep the thread and we can see how long it takes. Hash include uni std. So the sleep function comes from here, so it pause the execution for some time over there. So let's sleep here for a bit. um, let's leave the thread for here a bit, and then pthread mutex lock, because I'll be incrementing the ready value over here. So uh, and lock, and I'll do a ready plus plus, and I'll just print in the value set thread incremented ready to. %d slash n, and I'll print in ready. And then let's unlock the thread. Pthread mutex unlock and lock and return null. So this whole setter goes through, like, it sleeps here, and then it just increments the ready and then prints it and then unlocks it. Let's have the main function first. Int main. Um, or before that, we can have a waiter thread as well. So the waiter thread will also print in some value and then we can see. So void star waiter and void star arg. Let's have the mutex lock here. Pthread mutex lock and lock. So this will lock the resource over here, and then we need to unlock and return null over here. So I'll just paste it. Um, let's say while ready is not equal to 10. If this is not equal to 10, I'll just print the value of ready. Printf waiting ready is currently %d slash n. So it'll print the value of ready actually. And then it will be, let's say I'm just waiting I'll need to wait here. So before I get my ready as 10. So let's wait here, and then before printing, I'll just print the value of ready here. Printf final ready is %d slash n and a ready. Okay, so it means my ready needs to be, if my ready is not equal to 10, it'll be just it will be in this, like, in this loop. So if my ready is any variable, let's say apart from 10, it'll be going in this loop. So after this, we can have a main function. Let's say pthread p wait the thread, and let's create 10 set of threads to increment the value of ready. Pthread t setter of 10. So this will create 10 set of threads, and we'll be incrementing the ready one by one. So pthread create and wait a thread null waiter and another null, because we are not passing any value. And we pass in all of the setter threads. So this is the waiter threads. So now let's spawn 10 setter threads, which will increment the value of ready, and then our waiter thread should work. So it'll be for int I equals to 0, I is less than 10, I plus plus p thread create and setter of I null setter and null, and then we need to join all the threads for int I equals to 0, I is less than 10, I plus plus p thread join setter of I and some null, and let's wait for the last thread also to finish. So it'll be p thread wait a thread and a null, and then return 0. So what would we expect here? We would first want to increment the ready value to be 10, and then only the waiter function should go inside here and print the final ready here. So, but there's one problem here because we want it to be conditionally done. So we need to use this conditional lock as well. So how we can use this? So before, let's say, setter thread is set to ready, we need to pass in the value of the conditional. So we can just have a p thread. We can just have the conditional signal and then we just pass in and con. So this will trigger this conditional initializer, and it's just simple. We just add a conditional lock over here, like here, print pthread, pthread cond wait, and it will wait until my conditional condition is met. That is, my radius equals to 10, and then it will be going to the lock. And that's how you can have conditional locks here. So let me run this and GCC count variable and pthread. So there's any error. Okay, pthread create setter of I. Sleep void star arg and null. Oh, it should be setters. 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 Yeah. So it is waiting currently here, and then you print the ready is here. Set a thread, increment the ready to 1, 2, then ready is currently 2. So it will just wait here inside this loop and print the ready unless it's not equal to 10. And then it will print the ready once like final ready is 10, once the ready has been incremented to 10. That's how you can use conditional variable sync. So, but that's actually been rarely used. So, yeah. Any doubts till now? Any doubts or all good? Okay, I'll watch the recording. Okay, okay. So these were all the threads where we were creating and waiting for the thread using thread join. But let's say there might be a case where you want to just run the thread in the background and then just forget about it without joining it. So you can just use the detach mode over there. So let's see how we can have a detach mode and we can run the thread without just waiting for it. Thread detach.c. So let's have hash include stdio and hash include thread hash include um, uni std. So this is basically for this header file is just used for calling the sleep function, which will help your thread to sleep so that we can visualize how it's going through. So void star my thread, and it'll be a void star arg. And let's say for int I equals to 0, I is less than 10, I plus plus. I'm printing the thread is running. Printf thread is running %d/n. And let's print the number here. And that'll be it for this. And we can just return null because we don't want to return any value. So just return null and int main. Uh, p thread type p of p and pthread create and thread, sorry, and t null and my thread function and null because we're not passing any parameters. The original workflow which we used to do was pthread join and t1 and null and then return zero. So, okay. So this was the original workflow which we were doing. We just created the thread, wait for the thread execution to be finished, and then return. So let's just run this and see how would the output be. Thread detach slash dash p thread. And so it'll print this. This is fine because if you print, let's say here, printf control here. So it will first finish this thread execution, then only it will go here. So that's how the control flow is currently. But sometimes you want your main thread, your main process shouldn't be stuck. It should continue in the background. So what could you do for that? So there's a function which is called a detach function. You just run it in a detach mode and it doesn't require any function. So what will be the output here? So it will be created the thread, it will detach it. So detachment will run in the background and the main flow would still go on and it should print control here and then it should end because this would take much longer, but this will be very fast. So let's show here. So it prints control here, but it doesn't print this stuff because our main workflow finishes before this function ends. So just have a sleep here till so that we don't run out of time very quickly in the main flow. So we can have sleep of let's say 10. See, it prints thread is 0, 1, 2, 3, and 9, and then because it's sleeping, it just sleeps here for sleeps there, and then it will finish. So that's how it runs because it executes this and it executes this in the background. So that's much more beneficial when you want something to be run independently of the main control flow. Any doubts till now? Okay. Now thread pool now. What is a thread pool actually? So let's go to the slides. So thread pool is a creator of worker threads for task to execute. That means you just create many threads and you can just have them for the number of tasks. So let me show you how you can create a thread pool. So let's have hash include stdio, hash include pthread, and hash include stdlib. Let's define the maximum number of threads as three. Hash define max thread three and hash define num tasks as six. So we'll have a maximum of three threads and let's say have six tasks. So we'll have a p thread type T of thread pool and let's call it num threads, max thread, sorry. So let's create these many of threads and have a void star worker which takes in void star arg and it just prints in the task ID of it. So let's have int task ID equals to star of we need to dereference it first convert it to an integer pointer and then dereference it. So and printf thread ID is thread percent d Actually, it'll be LD actually is processing task %d/n. And let's print the thread ID itself. So it'll be pthread self. That's a function which will print the thread ID. And let's print the task ID here. And then let's free the argument and then return null. And let's have the main function and int star task ID. And for int I equals to 0, I is less than num tasks I plus plus. Um, task ID is equals to, let's malloc some tasks and int star malloc size of int. So it'll be um initializing I'm having like taking int size, and let's have the task ID as one, and let's create the thread here, pthread create, and let's create the thread from the thread pool. So it'll be thread pool of I% num max threads, because there might be a case like, because our max threads is 3, and but our num task is 6, so we need to change it to the appropriate value. That's why I'm dividing it by max threads, and null worker and the task ID, and then just wait for all the threads to finish. So for int I equals to 0, I is less than num tasks I plus plus, and pthread join thread pool of I% max threads and a null, because that's not returning any value, and then return 0. Let's change this to null. So it will be creating threads, and it will be going through the worker function. I will just print like the which thread is processing which task. So let's just compile and see. GCC thread pool pthread a dot out. So this is a thread which is processing task one. So all the tasks are there. Instead of I, let be I, and let's compile it again and see. So this thread is processing task zero. This is processing task one, and that's how you can see how many threads you can generate using thread pool. So I guess that was the last topic for threads. Any questions regarding threads? It's fine. Any doubts? Okay, I assume that's it. So next is after threads we are having like sockets. So socket programming. So what is a socket? So a socket is like an endpoint for communication between two machines. It's works similarly like reading or writing to a file, but it's over a network. So the common steps is like you create a socket, you bind it to a port, and then listen it. Either accept some request or rejects it. That's for the socket, and for the client, you just connect to a socket, and then that's it. You send in your data. So creating a socket is a very standard code. You just need to write it once and you're done. So let's just go over like what has been taught in the lecture for a socket code. Remember the one which are given in the lecture are just like basic sockets which are there on bare bones. They are not proper HTTP sockets. So if you try to do any curl request, it will fail because they don't have proper HTTP headers or stuff like that. So let's have a basic TCP server. So hash include stdio, hash include stdlib, hash include string, hash include probably I'll sleep over some point. So it's better to have a sleep also. So uni std. So one other library which you need for creating a socket is hash include rpa/inet. So this is not available on Windows, but it will compile fine if you are using any Linux version. So let's have an int main, and I'll take the port from the user and host a socket over there. So int argc and cast argv. So if argc is not equal to 2, printf to port number needed, and I'll just return from here. So let's just try initializing a socket. So const int port, we are assuming that the port will be provided by the user in the argument vector. So we'll be doing atoi argv of 1. So that'll have the port number. And so we need a server file descriptor. So I'll just write server fd and a new socket. These are some uninitialized variable which I'll have. So for there is a structure also which is provided by the rpa/inet, which is called a socket address. So struct socket addr in, so address address. So that is one of the structure which is provided by the C file. C this header file. You can click it and probably it should go. Okay, because that's this is VS Code which is not showing it the definition, because obviously the C the library, but it's there because you can compile and it'll see um, in addr length. So this will be the address length. It will be size of address, and then I'll have a cast star message. Because let's say we just send some message to the user who will just connect to our server. Let's say hello from the server. So server, that'll be the message will be sent by the server to every user who just connects to our server. So first we need to create a socket. So to create a socket, it'll be server fd equals to socket. Socket takes AFNet. That means it is of type IPv4, and sock stream, and this is 0. So that's the, if you go to here. So let me tell you what are these actually. So AFNet means it is basically um, IPv4 protocol. That's the internet protocol. SOCKStream means it's a TCP, which is reliable connection, and 0 is here like it's a default protocol over there. So that's a socket. So that's basically the default TCP over there. And now that's the port has been created. So there might be some cases where the port initialization could fail. We need to check that if server FD is double equal to 0, we can do p error socket failed, and then you can just exit failure. Now you need to create the socket option. So there might be some cases like when you create a socket, the address could be in use, but the address is not being used because sometimes some of the servers try to those addresses try to persist long over time. So that's why we create an opt equals to 1 and set sock s- sock opt and then server fd sole socket and so reuse addr, and we pass in the and opt and the size of opt. So what this function is doing, so this is actually creating, this is actually basically creating, saying the OS, I want this option so on my server. So it means, let's say if your instance of the server previously crashed, there'll be a time wait, but using this function, it won't be preventing those as like bind address already in use and all those stuff. And opt equals to 1 means that you are enabling the option to true, so that you are enabling the so reuse address. And then you just have your server configuration, that is address dot sin family equals to af afnet and address dot send addr dot s addr equals to inaddr any. So you are accepting connection from any of the available, like any of the clients. So you can change it if you want to accept connection from only some clients. And address dot send port. Here you just add the port, so it'll be HTONS port. Now you can have a check to see if your bind socket failed or not, but I'm just skipping it for now because we are a bit out of time. So listen, server FD and 3. So server FD and 3, that means your server could have listen to connections, and that'll be like up to 3 connections for a time. So printf server is running on port %d/n. That's port, and then just while one, we just create a new socket equal to accept the connection which is there. So it'll be accept server FD struct struct sock address addr address, and the socket length, that'll be sock length t, that'll be star addr len, and then it'll be if new socket is less than 0. So you just try to see if your new socket has been created or not. If it's not, then accept failed, and then you continue because you don't want to stop your server. And then otherwise, printf accepted, and then you just send the message which is a new socket message and str len message and then a 0. So that's it, and then you close. And then after you close the server, and then return 0. Let's try to compile this and see what will be. And GCC TCP server. Okay. Um, okay, here. Which line is it? ITUR and return. Okay, here, socklen will be this. Okay, I think that should be struct struct struct. Okay, um, that should be server FT AF inet. Um, address is unknown. Struct address is unknown. Let's try compiling this. Okay. Um, struct socket address and there's a spelling error, so it'll be SOCKADDR address, and then the address length will be this. If here it'll be inet, and I think that should be it. Okay, this is the problem. Socket length T, it should be a reference. Socket length T of ADDR length. Huh. Okay, that should be it. And then if we try to run it, a dot out, port number is needed. So let's run it on port number 3000. And the server is running on port 3000. And let's try to send in a connection request to port 8000. 3000, I mean. I'll just use netcat to send it. So it'll be echo hello and see localhost 3000. So a dot out 3000. Server is running on port 3000. What if we said printf instead of printer? What's the difference? That's fine. You can have a printf as well. I prefer to go with print error. That's one thing. So yeah, that's 3000 here. And echo hello and see localhost 3000. It's accepting the connection, but it's not printing it. So let's see how we can do it. Um, send message strlen message and zero. Let's see if the it's running on the port, and then bind accept failed, and we are not binding the socket to the port actually. So before here we need to bind the socket to the port. So if bind server fd struct sock addr um, and address comma size of address is less than zero, we just throw the error bind failed, and then exit failure. So I think that was the error. So let's recompile it, and let's just send Okay, there you go. It now sends hello from the server. So that was basically how you can create a TCP server. But again, it's not a proper HTTP server. So if you try to curl request it, let's say from Postman or somewhere else, let me show you. It will fail from Postman because it will send in some of the. It's running on 3000 because it will send in some headers as well. So which our server doesn't accept currently, and it will crash it. Let's say hello, and just create it, and then it accepts. But it says couldn't send a request, and let's send a get request. It is accepting, but the point when you wanted to send some data, let's say via post request, it will fail because it will give you some headers along with the request, and that will fail over there. Any doubts till now? Or I think that was it for the socket programming and concurrency.